Next, we're going to do more review, talk about simple interest and compound interest. And we want to look at the formulas a little bit and then do some problems. For the problems, I've looked at the random problems for the saving for retirement section. The first one, A, has simple interest, and then the hardest one is D, which is a complicated compound interest one. Before I dive in, I want to point out that these formulas spit out different things. The simple interest formula spits out only the amount of interest. If the problem says how much interest do we owe, that's great. That's what we want. Problem A fits that. However, if the problem instead asked what's the total amount that the borrower has to repay, then we would have to add. You'd have to take the loan and add the interest to it because they have to pay back the loan. If you go to your bank and only give them the interest and never pay back the loan, they're upset. It's opposite for the compound interest formula. The compound interest formula spits out the final amount, which includes the loan principal and the interest. So if they say how much is in the account at the end of all the years, that's great. That's what we want. But if somebody said, what's the interest only, then we'd have to subtract away the starting amount. So just a heads up on that. But these problems are all polite. They are asking for the thing that the formula spits out. The compound interest formula is based on how often does payouts happen? What's the rate per payout? What's the number of payouts? And some people don't like using a generic formula. So if you look in the notes a little farther down from this one, then there are different formulas that say if the interest rate is given annually, which it always is, then if it's monthly compounding, we need to divide it by 12. We need to split up the annual interest rate among 12 different compounding periods. Every month, something happens. And if they tell us how many years long the loan is, then we need to multiply it by 12 because each month triggers an event. Sometimes there is compounding quarterly. Sometimes stock dividends happen quarterly in real life. So then the annual interest rate has to be shared among 4 quarters. And if they told you how many years long this went on, you'd have to do a times 4 to say it happens 4 times a year to get how many times something has happened. I don't know anything in real life that has weekly compounding, so I'm not going to worry about that one. But I am going to say, this problem says that we start with compounded monthly and then go to compounded quarterly. So maybe people would prefer it if instead of the generic formula, we worked with just the monthly and quarterly versions of it so we could see how those work. Okay, that's my preface. Ready to start? Actually, I will also add that, again, there's nothing in the math about which type of interest this is. The people making the loan will say, I am giving you a loan with simple interest, like a bond or a bank certificate of deposit. And if that's the kind of loan, this is the kind of formula we use. Or the credit card will say, we charge compound interest monthly. And then that's what you have to do, because that's how they picked to make their loan. So this is about the design of the loan in real life. We can't just use math to know which formula to use. Okay, small business borrows this amount, 10% annual simple interest, and 130 days. I want a principal amount. That's easy. We have a size of the loan. I want an annual interest rate. The annual rates are always there. The years is what's going to mess us up. This loan has only 130 days. It's less than a year. So we want to write 130 days, not as 130 days, but we want to write this as 130 over 365 as a fraction of a year. If you don't like dealing with fractions, then just before we start the problems, we can turn this into a decimal. 130 divided by 365 gives me 0.3562, and I'm rounding a little, but who cares? Is it okay that we're looking at days and saying it's less than 1 year? So now I'm ready to plug everything in. So simple interest is 4,799 times 0.1. Where did we get that 0.1? Because we're doing 2 scoops to get out of percent format. And then we're multiplying by that 0.3562. And we're getting $170.94. Another problem exactly the same, different random numbers. We're again going to get out of the percent, left out of percent. And we're again going to say that 129 days out of 365 days is about what? 0.3534 of a year. And I get $210.36. Questions about this slide? Compound interest has a trickier formula. We're going to do very similar things. We're going to take the annual percentage rate and change it into a decimal with riplop. And we're going to say that we'll plug everything else in the formula. So this is a two-part formula. He's starting by investing $8,000 for 22 years in an account that earns 5% annual interest compounded monthly. So that's the part we're doing. We are not doing the second part. I'll do that on the next slide. Okay, for compound interest, it really helps to identify all the different things. So the principal is 8,000. The rate per payout we have to take that 5%, that 0.05, and share it monthly. This is for a whole year. So we have to do a divided by 12. To get how much it is per month. These sixes keep going. I don't really need to worry about that. If I write a bunch of them, it'll all come out okay because my answer is dollars and cents anyway. And then the number of payouts well, he has 22 years, but each year the bank gives him interest 12 times every month. So now we have a times 12. $264 different months. So my formula up above is that the final amount is that principal times. Now where there's 1 plus an interest rate per payout, I can just stick a 1 in front of this. I don't need parentheses. The parentheses are just there in the Word version. I can just put a 1 right there. And my exponent will be 264. And remember to use the exponent key on your calculator. It does not say EXP. That's for exponential notation, which is not part of this class. It looks either like a y to the x key or the symbol called a caret. So again, your exponent key will either be a y to the x or a caret symbol on your key. So do this with me. Make sure your calculator gets the same answer because otherwise you'll have trouble on the homework if the calculator is causing problems. So I got $23,978.46. Did you get the same answer on yours? Hang it up. So that's a whole compound interest problem. It's just that this is a two-part problem, so we have to keep going. Before we keep going, I wanted to compare these two things again. The general formula says we'll take the principal, we'll multiply it by 1 plus the rate per payout. And we put the 1 in front and the rate per payout there. And we had to find the rate per payout by thinking to ourselves, let's share this yearly interest rate among the 12 months because it's compounded monthly. It tells us that. And then how many payouts were there? We were thinking that every year there's 12 payouts. So we're multiplying and get this amount. If you like that general formula, great. But there was also this monthly formula that just put into it, divide by 12 and the times 12 so that you didn't have to kind of get your brain organized this way. It was right in the formula. So either way works. Okay, now let's do part 2. So whichever way you're thinking about it, now we are on compounding quarterly. So if you are working things out, thinking about things on paper, we'll have a divided by 4 and a times 4. If you're using the compounded quarterly equation, then it reminds you right there, you have a divided by 4 and a times 4. Okay, let's get organized. So how much does he start with? We're continuing where we left off. He doesn't add any money. He doesn't take something out to buy a new train. He just keeps that amount. So 23,978.46. The rate per payout. It's 3% per year, so 0.03 after doing decimal point scooped twice. Divided by 4. We have to share it among each quarter. So 0.0075. And the number of payouts. He has 29 years. Each year, he gets a little bit of interest 4 times. So that's 116 payouts. So his final amount is the principal multiply. We're going to take that 1 and just stick it in front. And our exponent is 116. And we get $57,048.95. People who are with me live, do you get the same answer?